Hey guys, welcome back to Geometry. This is your math teacher, Mr. O'Shea. Today we're going to be talking about 1-4, which is covering measuring line segments. So again, measuring segments. Now we're going to be talking about basically how long specific line segments are and how can we tell. Postulate 1-5. Now we have a lot of postulates. It's not important that you guys remember which postulate corresponds to what, but it is important that you do remember the main ideas covered. So postulate 1-5 states that the distance between any 2 points, it could be any, A and B, C and D, it doesn't matter. The distance between any 2 points on a line is the difference of the absolute value. Sorry, it's the absolute value of the difference. Let's write it like that. So again, the distance between any 2 points on a line is the absolute value of the difference between the corresponding values. That's a long one. Let's do an example problem of that. You guys can pause these too to make sure you get all the definitions. Let's do an example of that one. I want to find the length of AB and BC. Now what you guys might notice on this is that there's no line above AB. There's no line above BC. Anytime you guys just see it as AB with no line over the top, we're actually going to be talking about how long something is, the distance of it. So we're going to look for what is that actual distance. So when we're looking for that distance, again we write AB with nothing on top of it. That states that the distance of AB, we're looking for the difference of those two corresponding values. A is at -8 minus B, which is at -5. Now we know two negatives minus a negative really turns into addition. So we've got -8 plus 5, which is -3, but we need the absolute value. So the distance of AB is just going to be 3. How long is AB? That segment is 3. So again, let's do it now for BC. Again, no line on top of BC indicates that we're looking for distance. B is at, let's actually go with C. C is -2 and B is -5. So -2 minus -5. We're going to turn that into -2 plus 5 because it's minus a negative. -2 plus 5 is 3, and again we take the absolute value. So the distance of BC is 3. Alright, a little bit more abstract because we don't have a number line. Find M if the length of MN is 9 and the coordinate of N is 6. Now we don't have a number line, so it's always going to be very useful to actually go ahead and draw one out. And we know one coordinate, and that's N, which is 6. Now I'm just going to throw a couple of tick marks on both sides of this line here. And this specific line that I'm going to go ahead and count by, I'm going to count by 2's on both sides here, just kind of keep it short. So 2, 4, 6, so on and so forth. We're going to count by 2's. That means 1, 2, 3 to the left is going to leave us at 0, and 6, 8, 10, 12. It's going to leave us at 12 there. Again, I didn't do that for any specific reason, just more so save a little room on your papers. Now, we know that the distance is absolute value. What that means is essentially that MN could be 9 to the left. Maybe MN is 9 to the right. So we got to take this into consideration because we don't necessarily know where M is at. So I'm going to first go to the left. We're going to go 9 spaces. Now on a number line, going to the left would be negative. So essentially we're just going to go ahead and subtract. We know one coordinate, that's 6. So we would have to go, well, 9 to the left, that's going to leave us with 6 minus 9. It's going to give us -3. So that means that M, the coordinate of M, we know N, the coordinate of M could be at -3. That would be going 9 to the left. Now, that's not the only answer, right? We could go 9 to the left, but we could go 9 to the right. So we're going to say or, going 9 to the right, right is positive, so we actually got to add 9, so it's going to be 6 plus 9, which is 15. So in this problem, we don't necessarily know a precise answer for M. It could be -3, but it also could be 15. We know N is 6, could be either one of those two. All right, now we're going to a little bit more concrete vocab here. We're going to move into congruent segments. And anytime you have congruency, this is the symbol you're always going to use. Pay very close attention to that symbol. We're going to see it a lot in geometry this year. All right, congruent symbols, basically all that those are, you can think of congruency as like equals. That's kind of what the symbol looks like. So congruent segments are segments with the same length. Now it has to be the exact same length. So say for instance, no, we don't want that to be a line, we want it to be a segment. So we'll put an endpoint on it, we'll put an endpoint on that one. We'll call that segment AB, and we'll do another one over here, and this one will be CD. Now if I told you that AB was 5 inches long and it was congruent, well CD also has to be 5 inches long. And the way we would write this here, you guys, is that AB, now again notice that we didn't put a line over the top, so we're talking about the measurement of AB is congruent to the measurement of CD. Again, no line over the top talks about the distance, the length of AB. No line over the top of CD talks about the distance, the length of. Both of them are 5 inches. We consider those congruent segments. Another postulate to throw at you here. Postulate 1-6. If 3 points, we'll call them A, B, and C. So we've got 3 points. If 3 points A, B, and C are collinear points, now we know that that means all on the same line. If they're collinear points and B is in between A and C, you kind of picture that in your mind. B is somewhere in between A and C. Then maybe let's draw a little line, kind of get an idea of what's going on here. We got A, we got C, and we said B is somewhere in between. We don't know where, but it's somewhere in between. Well, if they're all collinear, then we know that AB plus BC is going to give us that whole distance of AC. Right? So the length of AB plus the length of BC, again, notice I'm not putting anything over the top, I'm talking about distance, is always going to be equal to the length of AC, that full distance. That's postulate 1-6. Otherwise known as the segment addition postulate. All right, so let's look at an example here. If dt is 60, so the whole length is 60, find the value of x, then find the length of ds and st. All right, so we know that ds and st, we got to add up to 60, right? Because the whole thing is 60. So we can say, all right, ds, that first segment, plus st, that second segment, that makes up the whole line, which equals 60, or dt. Now, if you guys notice there, all I did was use the actual variables. We used ds plus st, the segments. We named them. And we said that both of those make up the whole thing, dt. So all we're going to do now is swap out the actual letters, the names of it, for the expressions that are represented by it. So ds is really 2x minus 8, and st is 3x minus 12, and that all equals dt, which is 60. So now we've got some algebra we got to solve here. Hopefully you guys remember this, how to do these. 2x plus 3x is going to give us 5x. We've got negative 8 minus 12, that's going to give us negative 20. Right? Combine the 2x and the 3x to get 5x, and combine the negative 8 and negative 12 to get negative 20. Continue solving it from here. I'm going to add 20 to both sides. Cancel that out. Get the 5x all by itself. So now we're left with 5x equals 80. Well, we got to divide each side by 5 to get x all alone, and we're left with x equals 16. So we're done, right? Not quite, because we found x. But now we have to use that to find the length of ds and st. All right, we got x. Awesome. Let's go for ds. How long is ds? Well, here's the trick. All you got to do is take that 2x minus 8, and now we know what x is. We're going to go ahead and plug it in. It's really going to be 2 times 16 minus 8. 2 and 16 gives us 32 minus 8. 32 minus 8 is 24. So the length of ds, well, that's just going to be 24. Now, a couple of different ways that we can approach to find st. You guys do know that the whole length is 60, so you could use 60 in the 24. Or, what I prefer to do, is we're going to take st, and st was really 3x minus 12. And instead of the x, we're going to go ahead and use what we figured it out as, 16. So it's 3 times 16 minus 12. Now 3 times 16 is going to give us 48 minus 12, and 48 minus 12, well, that's just 36. So st equals 36. All right, if we wanted to test that, we would say 24 plus 36, because it has to add up to 60, right? The length of ds is 24. Plus 36 does equal 60. That checks off. We see our answer is correct. Fantastic. Midpoint. Midpoint's exactly what it sounds like. A midpoint is a point that is in the middle, right? It's actually a point that splits a line segment into two equal, but we're not going to say equal, we're going to use congruent. Two congruent, right? We'll say equal over here just so we remember what it is. It's a point that splits the segment into two congruent segments. Let's look at an example of that here. All right, C is the midpoint of AB. We see C, it's directly in the middle. We need to use that somehow to find the length of AC, the length of CB, and the length of AB. So we know AC here is 2x plus 1. Okay, and we know that that has to be equal to CB because C was the midpoint, right? If AC was like 12 inches long, CB would also have to be 12 inches long. So we know that AC is equal to CB. We're going to go ahead and write that over to the side. Now, hopefully you guys see these little dashes I'm putting on here. Right? I put 2 dashes on both those. We're going to talk about that later on, but that just kind of signifies that those two are congruent. Don't worry about that too much just yet. A little preview. So we've got AC is equal to CB. We said that those two would have to be equal. So really AC is 2x plus 1, and CB is 3x minus 4. All right, a little more advanced equation that we got to solve. Let's go ahead and eliminate the 2x on both sides. Okay, so we've got 1 and 2x. 3x minus 2x is 1x minus 4. All right, I want to isolate that 1x now, so I'm going to add 4 to both sides. And add 4 over here. And I'm left with 5 equals 1x. Or another way to write that is x equals 5. Now, unfortunately, that's not what the problem asked me to do. But I need to know what x is to be able to solve the problem. So we're going to keep going with these now. I'm going to use that x to find out the length of AC. I know that AC was 2x plus 1. Let's do it in red here, a little different color. All I'm going to do is plug in my x. It's going to be 2 times 5 plus 1. 2 times 5 is 10 plus 1, which tells me that the length of AC is 11. Well, now here's the deal. If it's the midpoint, we should know that CB is 11 too, right? But we're going to test it still. The reason I test it is just to double check my work all the time. So CB is 3x minus 4, but instead of x, we're going to plug in 5, so it's 3 times 5 minus 4. 3 times 5 is 15 minus 4. And 15 minus 4 is 11. Excellent. Now I know my answer worked because C was the midpoint. If AC and CB are both congruent, which they are, 11, then I know it worked out. All right, I also have to find AB. Well, I know AC is 11 and CB is 11. So I can say, all right, 11 plus 11, or AC plus CB, that's equal to AB, the whole thing. So 11 plus 11, well, that just equals 22. The length of AB, thus, is 22. Again, remember, do not put the distance, the line signals, or any of the ray samples or anything like that over the top, because we're talking about distance here. All right, one last one. A little trickier. Z is the midpoint of xy, and xy is 27. Find xz. Always draw these out, guys. We don't have a clue what this looks like until we draw it. So Z is the midpoint. We've got line segment xy. Now we know the whole thing, xy, that's 27. Let's write that in there. Now, do we know what xz is? We don't. We don't know what zy is either. But we do know if z is the midpoint, that tells us that it cuts it in half. They have to be two equal parts. So xz has to be equal to zy. They're congruent. So let's replace that. Anytime we're trying to solve something, we can use some variables. Let's go and redraw our lines there, right? So let's use the variable x, which means if xz, if that distance is x, then the other distance has to also be x. All right, I know that that segment addition piece, I know that the xz portion plus the zy portion has to add up to the whole thing. So we can write that out. xz plus zy, so the left side plus the right side, equals xy, the whole piece. Now xz, we called that distance x, and zy we also called x. I probably should have used a different variable there, guys. Hopefully that's not screwing you up too much. And that whole thing equaled xy, which was 27. All right, we got an equation. We can go ahead and solve this and figure out what x is. X plus x is going to give us 2x equals 27. We want to divide each side by 2 to get the x all alone. And we get x equals 27 and a half is 13.5. That's not what the problem asked, though. I didn't ask to find x, so we got to plug that back in. That just tells me xz was x, right? Man, that's really confusing. I hope that's not messing you guys up. When I say x, I'm really talking about the distance of xz. So the distance of xz is 13.5. All right, fantastic. All right, guys, you know the drill. Try the next couple of problems. Bring these back to class on Monday, and I'll see you then.